All right, for today, what I'd like you to do is have a piece of notebook paper out and a pencil as always. And what we're going to do is think about addition once again with decimals and fractions. And so what you have here is 456 plus 372. And what I want you to notice about this is when we add two numbers like this together, of course we start with the ones column and then the tens and then the hundreds. And when you add with decimals, you do everything the same. But the only thing that's different is you add the decimal point. So this is $4.56 or 4 and 56 hundredths, and this is 3 and 72 hundredths. So now this looks a little bit different than it did before, but the rules aren't any different. You just add the hundredths column, then the tenths, and then the ones. So let's go ahead and do this one together really quickly. So 6 plus 2 is 8, 5 plus 7 is 12, and the way I like to carry the 1 is I like to write whatever the answer is, so 5 plus 7 is 12. So I write the 1, 2, like I'm writing the number 12 left to right so that I know to carry the 1, because when I was your age, one of the common mistakes, I'll show you what I used to do, and this would impact my accuracy. I would say 5 plus 7 is 12, and I would write 1, carry the 2. And I thought, sometimes I was going too fast and I wasn't really thinking, so I thought, oh, that's right, and then I kept going, and then I'd get the answer wrong. So I really want you to see place value as we review adding and subtracting. So 5 plus 7 is 12, so 1, 2, and then the decimal point comes straight down, and 1 plus 4 plus 3, which is 8, right? So we have 8 and 28 hundredths. If we wanted to use money, we would put a dollar sign, okay? So that's just a quick review of adding. You haven't done it in a while, but I know you guys all know how to do it really well. So what we're going to do today is we're going to do some more story problems, and we're going to use bar models to solve these story problems. So again, what I'd like you to have is some notebook paper. You can just stick with the paper you've already started. And I'm going to give you a word problem, and I will read it out loud, and then I want you to think about what the answer is. And then we're going to solve it by using a bar model. And so adding and subtracting is something you're probably really skilled at. So what I'm wanting to do today is practice that and review it, but also kind of have you be thinking about bar models and how we can represent word problems with a bar model. Because what that does is prepare you for algebraic thinking and algebra class when you're in middle school or high school. Okay, so Pedro jogs 1.45 kilometers on Monday. He jogs 5/10 of a kilometer more on Tuesday than on Monday. How far does Pedro jog during both days? So I want you to think about what you think the answer is for a minute, and just go ahead and jot down your answer. And then let's see if it turns out the way we're going to do it right now. Okay, so what you're going to do is, to use a bar model, what we need to do is we need to draw a bar model. Yay, bar models. Okay, so the first thing we're going to do is we're going to represent Monday. So M is for Monday, and Pedro went for 1 45 hundredths kilometer. Right? Now the tricky part on this question is a lot of people would say he jogs 5/10 of a kilometer more on Tuesday than on Monday, so they add up 1 45 hundredths plus 5/10 and get their answer. But if you do that, you're not reading it clearly, because what the question is saying is, okay, on Tuesday, put a T there, he jogs 1 45 hundredths of a kilometer, but he goes 5/10 of a kilometer beyond, right? So that's what we need to figure out, is how much altogether. So here it says, how far does Pedro jog during both days? So your job now is to say, well, he did this much on Monday, this much on Tuesday, and this much more on Tuesday. So we need to write that down as an addition problem. So we're going to do 2 of these, and then he went 5/10 more. So we're going to write 5/10. And what I want you to do right now is I want you to check on your neatness, and I want you to make sure that you're writing really neatly so that you can make sure your place values are aligned. And what we're also going to do on this problem is we're going to add our placeholder zeros, just to help our eyes see what we have in front of us. So 5/10 has been changed to 50/100, which is still the same thing. And now we just have a simple addition problem. So 5 plus 5 is 10. And 1 plus 4 is 5. 5 plus 5 is 10. 10 plus 4 is 14. Oops, didn't do my method here. 1, 4. And then I'm going to put the decimal point, and then I have 1, 2, 3. So the answer is Pedro jogged 3 40 kilometers on Monday and Tuesday. That's our final answer. Okay, so that's just how to do a bar model. I'm going to show you a couple more that we're going to do together. So I want you to continue to write what I'm writing. And even if you are confused maybe about what I'm writing, I still want you to write it, because you will, if you engage with me right now and do this with me, whether you're confused or not, you'll eventually feel better about the learning if you have it written down, and maybe a light bulb will go on with bar models if you're a little bit confused about them. Okay. A length of ribbon is 1.25 meters long. Another ribbon is 0.75 meters longer than the first ribbon. What is the total length of the 2 ribbons? So this is a lot like the last one. A length of ribbon is 1.25 meters long. Another ribbon is 0.75 meters longer than the first ribbon. What is the total length of the 2 ribbons? So have you noticed that I'm forgetting to say 1 25/100? So I'm going to make sure I do that better starting now, because it's easy to say 1.25, but it's really 1 25/100 in math class, right? So here's the length of the ribbon, and it is 1 25/100 of a meter. Another ribbon is 7/500 meters longer than the first ribbon. So I'm going to make that longer, and I'm going to, this equals the same amount, and then we add 7/500 more, right? So now you can kind of clearly see what our addition problem is. We're going to add up these 3 numbers. So if you did not finish the bar model, I want you to do that right now, and just kind of get caught up. And if you need to pause, go ahead. And then over here, I'm going to do my addition kind of smaller. And so now my addition problem, I have lots of 5s, which makes me happy because they're easy to add up. Just count by 5s. I'm going to put a 0 here, and I'm going to double check that my place values are aligned and my decimal points are all lined up as well. And then I'm going to go ahead and count. So I have 5, 10, 15. And then I see a fast 10, which is 1 plus 2 plus 7 is 10. 10 plus 2 is 12. And then I'm going to add up 1, 2, 3. So I've added correctly, but I've forgotten to do something. What have I forgotten to do? My decimal point, you are right. I forgot to put my decimal point. And once you see this number without the decimal point, you can see how wrong it looks when we're adding decimal fractions, right? So our answer is 3 25/100. So that's the length that the ribbons are all together, the total length of the two ribbons. Let's do another one. Okay. So here's the next one. You can read it while I'm erasing. Helen has $2.40. She buys an ice cream for 85 cents. How much money does Helen have left? So you might think to yourself, I know how to solve this problem. I'm going to subtract. And you are correct about that. But what I want to see is, can you show this in a bar model, what this might look in a bar model? So think about that, and maybe even pause your video and see if you can turn this math problem into a bar model to represent it. And if you're not sure how to do it, you can just stick with me and I will show you. Either way is fine. So this is my first bar model, and this is how much Helen started out with. So how much did she start out with? $2.40, right? Okay. Now, what we're going to do is we're going to create another bar model that looks like this. And what I'm going to do is, I know this whole amount is $2.40, but I know that she spent 85 cents. So now what I need to solve for is what's missing here. And in algebra, we might call that Z, like give it a letter, like what is Z? Let's solve for the letter Z. We don't know. Or we could also show it as a question mark. How much money does she have left? So this is a subtraction problem. So what we're going to do is we're going to write down $2.40 minus 85 cents. And again, I'm going to put a placeholder 0. And again, I'm going to encourage you to check for neatness and just make sure your numbers are lined up so that your hundredths are ones on top of the other, your tenths is the same way, and so on. Okay, so here what we have is 0 take away 5, so we can't do that. So we're going to borrow a dime, and we're going to give 10 pennies, or the dime, over here, and we're going to have 10 take away 5. And that, of course, is 5. And then here, we can't say what is 3 take away 8. So we're going to borrow a whole dollar and leave it with just $1 because we started with $2. And we're going to give 10 dimes to the 3 that's left here. Now we have 13 minus 8, which is 5. And then 1 take away 0 is 1. And if you don't put that placeholder 0, I'll show you what that looks like. If you didn't put the 0 there, sometimes it's easy to forget that you have a subtraction problem. So I really encourage you to put the placeholder 0 there, because it reminds you that you're still subtracting. Okay, so now what we can do is we have solved for the question mark, which is $1.55. This is how much she has left. This has been spent and it's gone, but this is what she has left. All right. Well done. Okay, we're gonna do another one. And let's see. I think we will try this one. This one's a little bit different. So go ahead and read that to yourself. It says Susan is 25 or 25 hundredths of a meter shorter than Lena. Kelly is 75 hundredths of a meter taller than Susan. It should be Susan there. I don't know why that is that way. Lena is 1 meter tall. What is Kelly's height? So again, these are the type of problems that I do better with if I read them a couple of times. So Susan is 25 hundredths of a meter shorter than Lena. Kelly is 75 hundredths meter taller than Susan, and Lena is 1 meter tall. What is Kelly's height? Now you might look at this and say, I have no idea, and I don't even know where to begin. But what I like to do is I like to go with, what do I know for sure? And the problem has told me how tall Lena is, right? So I'm going to show Lena with an L, and she is 1 meter, right? Okay, now we can kind of do bar models for the rest. So it says Susan is 25 hundredths of a meter shorter than Lena. So how would you show that in your bar model? So I'm going to show it like this. And I know this missing part, or that she is 25 hundredths of a meter shorter than Lena. So I know this part. This is the part of Susan's height that I don't know. Okay, and you might be mental mathing that right now, which is great, right? Okay, if you're not sure, let's go ahead and solve for Susan, because I think that might help us with Lena. Okay, or actually help us with Kelly. So here we go. So we have 1 meter minus 25 hundredths, and that'll give us Susan. But what is wrong with the way I've set this up? Can you tell? I don't have my decimal points aligned, and I don't have any placeholder zeros helping me out either. So I'm going to make sure that I do that correctly. And the way I'm going to do that is 1, 0, 0, which means 1 and 0 hundredths, take away or minus 25 hundredths. And if you like to think about money, the way I do it when it comes to math is I see that it's $1 whole take away 25 cents. And just in my head, I know we're talking about meters, and that kind of helps me think of the answer quicker. So what we're going to do, if you don't know what the answer is, we're going to go ahead and subtract. Again, we have to borrow. So I'm going to borrow $1 whole, and I'm going to give 10 dimes to the tenths column. And then I need to borrow a dime to make this work. So now I have 10 take away 5 is 5, and 9 take away 2 is 7. And I'm going to bring down my decimal point, and I notice that there's just a 0 here, so I'm good. So now I know that Susan, or Susie, whatever you want to call her, is 75 hundredths of a meter. Okay, now Kelly is 75 hundredths meter taller than Susie. So what I'm going to do is erase this part, and I'm going to say, okay, here's Kelly, and I know this much is 75 hundredths, and then I know that Kelly is 75 hundredths more than that. So she's double the size, isn't she? Okay. What is Kelly's height? So now how are you going to solve for this problem? What is Kelly's height? So we know Lena's, we know Susie's, we need to figure out Kelly's. So what we can do is just add up 75 hundredths plus 75 hundredths and go ahead and add that up. And what I get is 1 50 hundredths of a meter. That's how tall she is. I could also say 1 5/10 of a meter. It would be the same thing. Okay, so what you're going to be doing today is you're going to be doing some real world math problems just like this in your workbook. And what I'd like you to do as you solve these is I'd like you to try to solve at least one of them with a bar model. And then if you have a different strategy that works just as well for you or even better, you can use that different strategy. But I do want you to try that bar model strategy because it's just good preparation for the future, and it's a different way to look at how we solve math problems. All right, I hope you have a good day. See you soon.